Now that we've talked about the different trunking modes, let's see how to configure a trunk between SW1 and SW2 that we saw in the prior diagram. Before we do any configuration though, let's check our current state. If we want to see how a specific interface is configured for trunking at the moment, we can give this command. We can say show interface followed by the interface identifier. We're using Fast Ethernet 1/0/2 and we give the keyword of switch port. And this tells us our current state. It says currently we're operating as an access port. Our trunking mode is set to dynamic auto. Remember, dynamic auto is willing to form a trunk, but it's not going to initiate that conversation. And the other end of this connection, the other switch, SW2, it's also configured for dynamic auto. Its port is configured for dynamic auto. And as a result, even though both ports are willing to become trunk ports, nobody is initiating that conversation. Nobody is sending a DTP frame. We're going to change that in just a moment. Something else we need to be aware of is the encapsulation type. If we do form a trunk, what encapsulation type are we going to use? Are we going to use IEEE 802.1q, which is probably what we want to be using in today's switches, or do we want to use ISL? Cisco had a proprietary trunking protocol called ISL Interswitch Link many years ago, and for a time Cisco preferred that we use ISL, but now Cisco is largely moving away from ISL and towards the industry standard of 802.1q. In fact, some of Cisco's newer switches don't even support ISL. We probably want to use .1q. And right now it's being negotiated, so that's something we would want to statically configure to say, if we form a trunk, let's form a .1q trunk. And if we form a trunk, we see that our native VLAN is going to be VLAN 1. We can also see if there are any trunks configured right now on the switch. Do we have any active trunks? To see that, we can very simply do a show interface trunk. And there's no output. We have no trunk currently. Let's change that. Let's go into global configuration mode and then into interface configuration mode for the interface that we want to be a trunk port. And before I change the trunking mode, I want to force the encapsulation to .1q. I don't want that to be negotiated because I don't want it to be ISL. Let's say switch port, trunk, encapsulation. We're set to negotiate currently, and we might negotiate ISL, and I don't want that to happen, so I'm going to hard code this to .1q. .1q. Now let's change our trunking mode from dynamic auto to dynamic desirable. We'll say switch port, mode. Here are our different options. We're going to say dynamic, and I'm going to say desirable. When we do that, we should see some console messages start to pop up indicating that this interface has gone down and then come back up. And we see that on screen right now. Let's see if we have a trunk. Let's once again do a show interface Fast Ethernet 1/0/2 with the keyword of switch port, and now we are operating as a trunk. We were accessed just a moment ago, now we're trunk. We were dynamic auto a few moments ago. We changed that to dynamic desirable, causing the trunk to be formed. We also said we don't want to negotiate our encapsulation type. Let's hard code it to .1q. We see that our native VLAN is VLAN 1, and we can go over to switch SW2 and confirm that it is also seeing the trunk. Let's do a show interface gigabit 0/10 with the keyword of switch port. We're set to dynamic auto on this side, but that's okay. The other side, SW1, initiated those DTP frames, so we agreed to become a trunk. We negotiated, based on what the other side told us, we negotiated our encapsulation type, and we negotiated .1q. Our native VLAN is 1. We could also give the command show interface trunk to see the trunks or trunk configured on this switch. This was negotiated. That's what the N means. We negotiated .1q. We're trunking. Our native VLAN is 1. Let's take a look at SW1. Let's give that same command. Let's do a show interface trunk. Almost the same thing here. Instead of negotiating .1q, we had hard coded that on this switch. The mode is desirable instead of auto. That's what we had on SW2. We're trunking, and the native VLAN is 1. We also see what VLANs are active and are in the forwarding state for this trunk. All three of our VLANs, VLAN 1, that was created for us by default. We earlier created VLANs 100 and 200, and all three of those are permitted to go across the trunk. We've now configured an IEEE 802.1q trunk between a couple of our switches, and we can see from this output on screen, the show interface trunk output, that our native VLAN is 1. That's the default native VLAN. We may, as part of our design, want to change the native VLAN. If we do that, the other end of the trunk needs to agree what the native VLAN is. Otherwise, if I send an untagged frame to that other switch, and it sees that untagged frame, it's going to assume that that frame belongs to the native VLAN according to the other switch. If I think the native VLAN is 100 and the other switch thinks the native VLAN is 200, then that's going to do something called VLAN hopping. We don't want that to happen. Let's make sure that both switches agree on the native VLAN. Here's how we change it. Let's go into interface configuration mode for our trunk port. It's Fast Ethernet 1/0/2, and I'm going to say switch port trunk, and using context-sensitive help, we see that we can specify our native VLAN. We'll say native VLAN, and let's make the native VLAN 100. And we're getting some error messages on the screen. It says that we're inconsistent with our peer. This is not good. We need to go set the native VLAN on the far end. Let's just make sure that we have set the native VLAN on this switch. Let's do a show interface trunk, and we can see that our native VLAN is 100. Let's go to switch 2. On switch 2, let's do a show interfaces trunk. We're still set to a native VLAN of 1. Let's change that. Let's go into interface gigabit 0/10 on switch 2, and let's say switch port trunk native VLAN 100. And we saw that we got a native VLAN mismatch error message on SW2. That should be resolved now. Everything should be good. Let's confirm it. Let's do a show interface trunk. Let's make sure we have a native VLAN of 100 on SW2. And we're starting to see some spanning tree restored commands. Those are good messages. We haven't talked about spanning tree yet, but those are good messages to see that something has been restored. And it looks like everything is up and happy on switch SW1 again as well. What we've done in this short video is to show you how to specify a non-default native, in other words an untagged VLAN, going over a trunk. We've now configured a trunk between a couple of our switches. We've set the native VLAN to a non-default value. One other thing we may want to do is to limit what VLANs are allowed to cross that trunk. If we take a look at our current trunk configuration, if I do a show interface trunk, you'll notice that all three of my VLANs, VLAN 1, which was created by default, VLANs 100 and 200 that we added earlier, notice that they are all allowed. They're in the forwarding state. But let's pretend that for design reasons, for security reasons, for some reason, we did not want VLAN 200 to go across this trunk. How could we prevent that? Let's go into that interface. Let's go into interface Fast Ethernet 1/0/2, and we can say switch port trunk allowed VLAN, and context-sensitive help gives us several different options. I could just give a listing of VLANs that I wanted to allow. However, if I've already done that and I want to add an additional VLAN, I could use the keyword of add. If I wanted to remove one of the VLANs that I've already added, I could say remove. If I didn't want to allow any VLANs, I could say none, or I could say all to allow all VLANs. That's what we have by default. If I want to allow all of the VLANs except one or more specific VLANs, I could say except. So we've got a couple of ways we could do this. I could say switch port trunk allowed VLAN 1,100. That would do it. And we can verify that with a show interface trunk command. You see that VLAN 200 no longer listed. Another way we could have done that, and I'm just going to scroll through my history buffer by pressing the up arrow. Let's go back into the interface. And we could say allow everybody except 200. And if we give our show command again, we get the same result. Those are a couple of different ways that we can prevent traffic from a specific VLAN, or we could have specified more than one VLAN. We could have used, and here's an example of that, we could have used a comma separator, we could have given a range of VLANs with a hyphen, but we could specify one or more VLANs that were not allowed to cross this trunk.